19, you said? I have no idea why I have the 18 theme song in my head. Anyway, so why are you looking at me with such disdain? I'm nice to you all the time. Zeros. It'll be x minus 1, x minus 3, x plus 2. And then I have ordered pairs of 2 and 1, substituted for x and 1. When I do that, I get 1 equals a times 2 minus 1, 2 minus 3, and 2 plus 2. One of the things that I would suggest that you guys do, because I know that none of you would ever make a stupid mistake, like mathing, because that would never happen. Because why would it, right? What I would do is this. What? I would take away the possibility of screwing that up. I would type in my calculator, parentheses 2 minus 1, parentheses 3 minus, or 2 minus 3, parentheses 2 plus 2. Just that way I know I won't screw up. All right. So you don't make a dumb mistake. I know. I'm just saying. I may or may not have done this once or twice where I know that people make dumb mistakes. I'm trying to show you where you make dumb mistakes, and that's where you make dumb mistakes. So just trying to help. Is A, what's A? I forgot what I was about to say. Yeah, negative 1/4. Negative 1/4 then for the A value, and then you just use that and rewrite with those zeros that were written first. Okay. Winds up, it's very similar. Remember we did that intercept 4 in quadratics? Basically the exact same thing with 1 extra 0. Like I was telling the 11th hour, I increased your workload by 50%. Good morning. Do you have a dollar? My wife took my money. Not like I needed it. All right, I'll take it. Which one? I'm sorry, I wasn't listening. On which part? 6.8? 6.8? What number? 16. Gotcha. Sorry. I really do pay attention when people talk. All right. What degree is this going to wind up being? It's going to be a 4th degree polynomial. My zeros are located at -2 and -4, and they have multiplicity, which means they're going to change direction at both of them. So those are my zeros. Are these going to be, since it's 4th degree, are we tails up or are we tails down? Tails up, okay. So we're going to do this. Hi. They do. Whenever you have multiplicity, you change directions at 0. You follow from where your tails were. In this case, we only have those 2 sets of zeros, and our tails were up. We're okay with that, correct? So that means that no matter what, I'm coming down towards that -4 as a 0. Once I hit it, I have to go back up. And then I have to change direction somewhere to come back down to the -2, 0, and go back up. Now, if this happened to have let's say this had that out there. Where's the other 0 going to wind up being? Be at -5. My tails are still up. Do you agree? Okay. My tails are still up, but what happens when you have a regular 0? It goes through it, changes direction. This has multiplicity, would change direction. This would have multiplicity, it changes direction. And would do this. Now this would be correct because it'd be down, or be up, down, excuse me, because it's a 5th degree now. What happens is whenever you have multiplicity, sorry, I was thinking of the, it didn't do anything, did it? Sorry, sorry, Bill. I was thinking still of having the 6th up 4th degree there when I was doing that. I was going up like this, so it would have gone through. It would have done that. Okay. So the idea is, remember, you guys have graphed that before. Remember when you had x squared minus 6x plus 9. What times what's 9 you add together to get -6? -3 and -3. That means you had zeros at 3 and 3, which meant that it touched the x-axis once at 3, y-intercept of 9. Axis of symmetry was at 3, and so on and so on. Okay? It's that same idea, but instead of just being a quadratic, instead of being a regular old boring quadratic, we're looking at higher degree polynomials. So it's whenever you have a double, it just touches and goes. Okay? Or any even, I should say. No, I always try to throw it up. I can't even do one right next to it. It's a long-standing thing that I try.
Tomorrow?
I'm going to let you guys have the multi-use. No. Yes. Yep. And then the word problem will be a separate one that you'll have to use the table. You'll have to use, or maybe, I don't know. Sir, we are going to start section 9.4. The last unit that we talk about, or one of the last ones, because we'll probably be able to sneak in just a very small amount of chapter 7 as well. One of the last units that we talk about are rational expressions, and it has to deal with a lot of factoring. So we do that after we do polynomials because you guys have been factoring for so long. Might as well continue doing some factoring stuff with multiplying them and dividing them and adding them, subtracting them, and solving equations and all that because you've been doing this for so long. We like to seek that in all during the first semester because it's all kind of the same generic idea. Second semester is when things go awry, but not like really good. What else we got? That would have been awesome. No. Remember the tally's for this guy. The difference. This one is the one that I do this to all the time. This one is not weighted well enough to do that. See? What? Good morning. Yeah. If a goose hit that window, it's like, ah! You know, I mean, it's the I have not yet seen a goose run into a window. I know, right? It would be awesome if it did happen. It'd be pretty funny. What's that? I bet you they're up there. I would imagine there's city windows. And you guys are moving? But no. Yes, sir. Yes, there was one where the bird flew towards it and stopped and it went away. Yeah, I guess the other ones happened. I know that I remember seeing one. Yeah, where the bird hit, and I think it happened, then it happened again later on. The third one came from a different class, like I think with one of Miss Miller's classes, where a bird hit the window. So it's kind of a weird occurrence. It doesn't happen very often, but this year. I haven't seen a bird hit a window. We did see the other day during 11th hour. What was it Tuesday or Wednesday of last week? Christina and Maya saw this too. If I'm standing here, you guys see where the stop sign is? So see, going past the stop sign, the little grass, I don't know, parkway, if you will, on the other side of the street there. Well, that goes down obviously towards the field. All right. So something really, really, really big was walking through there, like animal wise, because I saw the back the back of the tail, or not the tail, but I saw like the body of it just kind of walking through. I'm like, holy crap! And he's like, wow, look at the size of it, and then it just kind of skirted away. I'm like, I wonder what that was. So I even texted. I wound up texting Lockhart later on during Flex, because I know he doesn't answer emails like that, so I just text him. I say, hey, do the security cameras face that intersection at all? I goes, we saw something really, really big walking on that parkway. We were trying to figure out what it was. And he's like, no, they don't face that woman. This is so sad. We really want to know what it was. You guys really don't care. Review sheet. Let's look at that. See how we were doing on there. Yes. Yes. Oh, yes. I don't have time to write passes. Why don't I waste my time? I got stuff to do. We got things to do and places to go, people to see, right? They'll be fine. Why are you trying to eat your ink? It's weird. I've talked with you more now today, like I have all year. It's like him talking yesterday. It was really, really weird. I don't like this. This group up here is starting to talk more. Thank goodness I won't be here most of the second semester. Because you'll. I know. She's been teaching a lot of the other stuff because when she's here in the mornings, she's only here for really 2 class periods, so it's hard to get rolling. When she's here in the afternoon, she's here for 3 of my classes, so she's getting to a lot. So it's just getting started and go. She'll take over. Second semester, she'll start with all of my geometry classes right away, and then by the end of January, she'll be in here. Well, she'll be in here all the time, but she'll be doing more. She's gonna be great. Don't roll your eyes. Do you think I would have one? Do you think I would have one that would be? Do you think I would let something bad ever happen? Yeah, some days I would, but most days I won't. All right, review stuff. Anyway, back to this good fun stuff, because this stuff is awesome and fun. One of the things to remind you guys of when you are adding and subtracting with polynomials, rewrite them, put placeholders. It's very simple to make silly mistakes like you guys have done once or twice or often. So just be careful with it. Okay? There's really no rhyme or reason. It's just taking your time and make sure you go through those correctly. Long division. That's what it says. Oh, you are nice.
I know.
Should have hit your stuff. Let's do this one, guys. So long division, just in case you forgot, because it's so awesome. What is your goal? So, yes. solve it out, but what do you always want to, what are you doing to solve said equation? Divide. All right, thank you. Basically, my question is, what do you multiply x by to turn it into x cubed? X squared. So where above this list of numbers do you think you should place it? How about that? How about that? Distribute back in and subtract. Make sure you write the subtraction symbol twice so you don't make a dumb mistake. Because, like I said, you never do that. Subtract out, you get 8x squared. Bring down the 58. What do you multiply x by to turn it into 8x squared? 8x, very good. Remember to always keep the same sign, whatever you're multiplying by, to turn it into. Bless you. Bless you. 58 subtract 64, I believe, is negative 6. Does that sound right? What do you multiply x by and turn it into negative 6? I should have said negative 6x, excuse me. Distribute one more time. We have negative 6x minus 64. When you subtract the negative, you in fact are adding. So negative 41 and 64, I believe, is what, 23? Oh, I looked at the 8 when I wrote it, so it should have been 48. Sorry about that. When I was looking over, I glanced back at the 8. I thought that was the last number I wrote down. That's why I wrote 64. And then from there, I would do. Right, I know. So minus to negative 48 is positive 7. And then what do you do with your remainder? Put it over the x plus 8 like that. And there you go. 473. Less than.
Oh my gosh.
I love the torment. It's great. Factoring. 4 terms. Which ones? Sure.
I did that.
So this one said factor. Did it say solve for zeros? No. So if it says factor, what do you have to do? Factor. So this one is a sum of cubes. Now, if you recall, there was a special pattern for that. We had, if it was a cubed plus b cubed, it wound up equaling out a plus b, a squared minus ab plus b squared. If it was a cubed minus b cubed, it was a minus b, a squared plus ab plus b squared. Those were the 2 special patterns. Okay. Remember, the first one was the same sign, and then when the next time you write a sign, it's always opposite, and then the last sign is always positive. So it's always going to be same, opposite, positive. Same, opposite, positive. Stop. I stop for you, and I stop the world, and I melt with you. Sorry. I think you were going like, am I going to give you those? No. Sorry. Didn't mean to laugh like that. I didn't give it to you. Did you write them down? I bet you guys are like so happy when you're done with this class because then the rest of the day you don't get harassed as much. Sorry. All right, so what we have to do first of all is whenever you're factoring, your first rule is always to find GCFs. So these two guys are happen to be even. So what should you take out?
A two.
2. If I take out a 2, I'm left with 64x cubed plus 27. Since this is a factor problem, can I get rid of the 2? No.
Oh.
Since it's a factor problem, I cannot get rid of the 2. If it was an equals or solve for zeros, then I can. Since it's not, I can't do that. I have to keep the 2 there all throughout the process. So now, what is the cube root of 64? 4. What's the cube root of 27? 3. So what we want to do is think of this as 4x quantity cubed plus 3 cubed. Remember to group that first term's coefficient. That's where you'll make a silly mistake. Okay? Go through the process now. We have 2 times the quantity 4x plus 3. Now it'll be the quantity 4x squared, which gives me 16x squared. Now then it'll be minus 4x times 3. And then it'll be 3 squared plus. Exactly. Now, if this was an equals 0 problem, then you would find your zeros. One of them is really easy, -3/4. The other one you have to do, quadratic formula. Quadratic formula.
Well, you feel like, never mind.
Over 2a, over 2a. Yes. What? No. This guy, whenever you factor or solve for zeros for a sum or a difference of cubes, the trinomial that's created will never be factorable. Quadratic formula. Sure. Waiting. If it had a solve for 0 to it or an equal sign, yes. This one just said factor. And yes, you would have to use quadratic formula for that part here. Subtract 3 divided by 4. Just set it equal to 0. It's like a regular term would be done, just like a regular old boring term. Okay. 8 is what? 250x cubed plus what? 250x cubed plus 2. All right. GCF is 2. You get a 125x cubed plus 1. 125's cube root is 5. Cube root of 1 is 1. So you get 2, 5x plus 1, 25, x squared minus 5x plus 1. What did the answer of x say? Remember the pattern. A plus b, a squared minus ab plus b squared. This guy is a is 5x. You have to remember to square the 5. That's where people forget. That's why you always got to group. That's why I always throw parentheses around it when I rewrite it as 5x quantity cubed, so that way you know what the cube root of 125x cubed is. Okay. All right. Second page. How are we rolling? Uh-huh. Yes, ma'am. Good question. Good question. You said number 12? Yeah. Okay. Let's look at it just for fun. Because it says find all zeros. I like finding zeros. They're fun. In theory. Because you hate me. What times what's 25? You had together get negative 26. Negative 1, negative 25. Very good. Yep. You can factor it like you would any other normal trinomial. it's written like that, it's hard to have. Otherwise, if you wanted to use synthetic, you can use synthetic as well. You just have a whole bunch of placeholders. Yeah, where you go? So now, those are both differences of squares, aren't they? So we have x squared minus 5, x squared plus 5, x squared minus 1, x squared plus 1. So far, so good. We're still on the hook for having 8 total zeros. Since this is find all zeros, do I have to factor this any further, or can I just start listing zeros? I can start listing zeros at this point. That's absolutely fine. So my first one would be plus or minus the square root of 5. My next one would be plus or minus I root 5. The next one would be plus or minus 1. And the last ones would be plus or minus I. I can do that at that moment there, since it is finding all zeros. Can you get that? And hopefully, if I count that correctly, there's 8 of them. If there's 8 of them, that's a good deal. Hi, how are you? $2. See, he's not as cool as you. He didn't offer him that 5. Lame, I know, right? That's true. You didn't have $1. You're right. Grab it. You said 9. I forgot. Short attention span. I didn't use it. Look, squirrel. So one of the tricks that I was trying to show you guys is whenever you have 4 terms, what should you always try and do right away? Group it. So set this one. Try to group it how it sits. When you group it, GCF, you get an x to the 4th, x squared minus 2. Take out a negative 4, and we get an x squared minus 2. That gives me x to the 4th minus 4, x squared minus 2. Bless you. And then that gets me one more set of differences squares for the x to the 4th. So I have x squared minus 2, x squared plus 2, x squared minus 2. And from here, I can go ahead and list out all of my possible zeros. I have plus or minus root 2 with multiplicity of 2. I was just doing this first one. And the reason why I'm doing that, because the reason why I'm saying the multiplicity right away, because these guys are the same. So I'll have plus or minus root 2 twice. That takes care of 4 of my zeros. The other ones, like you were just saying, would be plus or minus I root 2 for the imaginary set. And that's what that would look like. List all your zeros. When you have multiplicity, just write down with multiplicity of however many you have. Does that help? What's that? What do you got? Yeah, one times 1 is 14, and the other negative 9. Yep, absolutely. You get negative 7 and negative 2. Now look at help you. It'll say if multiplicity, just write it out. Okay, because basically what I'm just going to have you guys do is find all zeros. I'm not going to ask you to write, find only real answers. We're just going to go for the whole thing. That's more fun. And then if it's just a general consensus that we remember that if there's multiplicity, just state it. I'm good with that. Cool. Are you good with that? Everybody, Belle says she's cool with it, so everybody else is cool with it now. Air 5, Belle. What else we got? Yes, sir. 11. What times what 16 you add together to get negative 17? Negative 16, negative 1, then you have 2 sets of difference squares. Good. Right. So continue. How are we doing with building functions with coefficients? Good. Are you using the shortcut? Like, for example, if I look at 16, that's about as weird as it can get. So this is going to be a what degree polynomial when you're done? Should be a fifth degree, very good. Because you already have a 2 plus 2i, which means there should be a 2 minus 2i, and there should be a 1 plus 2i. So let's see if we can figure this out cleanly. My 0 is 1, what's my term? I knew what you meant though, yeah. And then, do you guys remember the shortcut when we were writing it out in terms of a plus or minus bi for how to do that? Remember, all that winds up being is going to be x minus the a quantity squared plus b squared. It'll always be that. So this one would wind up being the quantity x minus 2 squared plus 4. The other one would be x minus 1 quantity squared plus 4. Because it's 2 squared. And then you just have to FOIL those out individually and add the 4. FOIL out the other one, add the 4. So you get x minus 1. This is x squared minus 4x plus 4 plus 4. So you get x squared minus 4x plus 8. And this one would be x squared minus 2x plus 5. And then unfortunately it's just a lot of distributing. And that's how you get your fifth degree. It's a nice little shortcut. No, remember, what's 3 times 2 times 3? Okay, so what's 3 times 3 times 2? What's 2 times 3 times 3? And then what's 3 times 3 times 2? Do the order in which you multiply matter? So what you're doing here, you're not sending it to both this one and this one. What I would do is just send, first of all, just send it. Actually, you know what I might do might be a little bit cleaner. Put those two together because that's going to take the longest. And then distribute the x to all of them, and then distribute the negative 1 to all of them. It's just going to be a really long, nasty looking ugly thing. I think we're down. I'm whittling it down in my brain right now. We're down to about like 462 right now. So, yes. What's I squared? Negative 1. So no matter what, when you went through all that, remember how we distribute through? I always want to be minus something with an I squared. That negates it, just becomes plus. It's just a shortcut. Yeah, Bill. Uh-huh. Uh-huh. By doing it this way, this is why we're getting rid of the I squared, because when you have minus that coefficient, you get minus a negative value because the I would be a negative 1, and then it becomes plus right away. So we're shortcutting it by just saying plus b. Because if you did this long form, this would have wound up being minus 2i quantity squared, which would have been minus 4 times negative 1, which would have been minus negative 4, which is plus 4. You would have gotten to that eventually. I'm just saying, screw it. Just write it as plus 4. Because it always happens. So when, yeah, you know, eventually it'll look like that. If you square that, you get minus 4 times negative 1, which is, that's where I'm going with it. It'll always work. I'm trying to help you guys with just a nice little clean shortcut. In front of the I? Yeah. Yeah. It's kind of nice. Yay math. Not yay math. It's back. Both through kind of like. Oh, what? Hi. Yes. Good to see that million. Hey, what else you got? Good deal. I'm going nice. Oh, it's on. It's on.
I'm trying to get them to like, hey, so we can go in here and do the program and be like, circumcenter, or take the bisector, like do things. And they were like, no, that's like,
That's awesome. Hey, it's like you got toilet paper stuck to your foot. That was pretty funny. Good.